So we've been talking about conceptualization, how we sort of think about concepts in the social science, but that conversation has largely been sort of on the philosophical level. It hasn't been more focused on sort of the mechanics of how do you take a concept and turn it into something that you can build a chart out of or a table or run some sort of analysis on. And so I'd like to talk a little bit about that today, the sort of mechanics of taking concepts and turning them into variables, things that we can work with. And so we'll kind of talk about a variety of different variables and the kind of analysis you can do with them and kind of touch back to when this might be an appropriate way to express a concept. So I'll start with talking about string variables. These are variables that can take on basically any value. There's no real structure to them other than they hold characters, and they can hold any characters. And so if I conduct interviews, I might record the names of the people I interviewed as a string variable. Right? It's just a string of characters. I could also record their phone numbers, string of characters. They happen to be numbers, but the numbers don't have sort of mathematical meaning. They're an organizational kind of thing. And it wouldn't be appropriate to do math on those kind of numbers. I could have notes or comments, or even the full interview transcripts could be included as string variables. And typically with string variables, when they're included in data sets, they're included for organizational purposes. I need to be able to sort alphabetically. I need to be able to link this data set to another data set. They serve sort of a practical functional purpose. If you have large blocks of text, however, you might be able to use those with some sort of text analysis software and turn them into something else. But typically they're hard to analyze large blocks of text in a database kind of situation. So string variables are practical, but we're probably not going to be doing a lot of analysis with them. Another kind of way of organizing information is as a categorical measure. And so there are a lot of situations, I think particularly in the social sciences, in which we're interested in things that can take on a very limited number of values. And each of those values represents sort of a category. And in an ideal world, you would be able to say, okay, I'm interested in these cases, and I can sort each of these cases into these 4, 5, 8 categories, and that's logically exhaustive. Every single case I have, I can find a box for, and every case fits in neatly into one box. And if I'm sort of brainstorming, I can't come up with a box that's missing that I might need someday. I've kind of got a framework that captures all the possible categories. Now, noting that there are lots of situations in which we're sort of thinking about our concepts as having these attributes that are categories isn't enough. We also need to know a little bit about how those categories relate to each other, because depending upon if your categorical measure is a nominal variable versus an ordinal variable versus a dichotomous variable, that's going to have a big impact on the kind of analysis that you can do with those variables. And so again, having some sort of sense philosophically about how these things are set up is going to be helpful. So I'll start by talking about nominal variables. Nominal variables are categories that don't have an internally logical order for their arrangement. I mean, I suppose you could alphabetize them, or if you had sort of a 1, 2, 3, 4 sort of coding scheme, you could sort them in order, but that order is arbitrary. That order doesn't have sort of a deep mathematical meaning. It doesn't have a logical meaning. So these are things like region of the country. And if I had, Northeast, Southeast, West, Midwest, whether I call Northeast 1 and Southeast 2 is a completely arbitrary decision, and I could flip-flop that coding around, and it would be really hard to make a case that one region is more or less than another region, at least not in a way that's going to be compelling to people. Similarly, religion is a really difficult thing to try to rank and order in terms of, I don't even know how you go about trying to rank or order religions or occupations or any number of things that we could have distinct categories for. But other than describing those categories and noting how many people are in each category, I'm not sure what else to do. And so if we're analyzing these, we're maybe looking for the mode as a way of measuring sort of what's common, the central tendency, the mode being the most common category. We could be sort of doing tallying and counting with pie charts and bar charts and that kind of thing. Maybe we're making tables Statistically, we can analyze this with the chi-square test, which looks at a table and asks if the cases are in sort of an unusual configuration. We've got a bunch over in this cell and very few in this cell, and maybe that tells us something about the table behaving in an odd way. But that's about it in terms of statistical analysis that we're going to be able to apply to nominal variables, with some caveats that I'll sneak in later. Sometimes our categories are ordinal in that there's sort of a logical order to how they're set up and how they're structured. And so things sometimes just have this as sort of a natural part of how they are. So Likert scales are oftentimes analyzed as ordinal variables. So Likert scale is sort of that 5-point scale that goes from strongly disagree to no opinion or neutral to agree to strongly agree. And we can say that as you're moving across that scale, you're going from strongly disagree to agree, and there's a meaningful variation, and that's the appropriate way to organize it. You would never sort of put, agree and disagree on this end and strongly agree and strongly disagree on this. Well, maybe you would. If you're thinking about intensity of feelings, that would be a different order, ordinal variable, measuring intensity of feelings. It wouldn't be a Likert scale. So there's an implied order, highest degree earned is another good example, right? So if you're going from elementary to middle school to high school to maybe associates or bachelor's or graduate school, there's sort of an implied sort of number of years of school that goes along with that. And so we can maybe put things in order and say less school, more school. Okay. We can't necessarily mathematically manipulate ordinal categorical variables. They may have numbers attached to them. I may count that Likert scale as -2, -1, 0, 1, 2, and that might be handy for sorting them in the appropriate order, but I can't really say that strongly agree is twice as much as agree. I mean, I guess I could say that, but it would be an arbitrary thing to say. I could give the values of -5, 1, 0, +1, 5, and that would also work in terms of sorting the order. But now I've created a situation where strongly agree is 5 times as much as agree. The numbers that we use for these categorical variables don't necessarily correspond to math in the way that we tend to think about it. And so again, we're stuck with looking at mode, most common category. We can do median now because we're just looking for the sort of middle when we line things up from smallest to largest. What's sort of that middle point? Again, tally graphs with bar charts and pie charts. But when we're thinking about looking for patterns, we can do a little bit more than just the chi-square of, is there an unusual number of cases in this cell? We can also do something that looks a little bit like correlation. And there's a variety of techniques. I'll just reference gamma because I think it's the most robust of the various categorical correlation techniques. But it's asking the question, so as one ordinal variable goes up, does another ordinal variable go up as well, or does it go down? And we can kind of measure that and keep track of that. So we can get a sense of patterns with ordinal variables. And then lastly, when we're thinking about categorical variables, we have dichotomous variables, which are commonly referred to as dummy variables. Although I worked for a historian who really didn't like it when I called the variables in his data set dummy variables. He said they were smart variables. He didn't like that phrasing. And so I just changed all my references to dummy variables to dichotomous, because it means basically the same thing. You can have 2 variables. It can be yes or no. It can be, did you vote or not vote? Are you a member of this group or not a member of this group? Anything where you can sort of dichotomize things out works as a dummy variable. Historically, gender has been oftentimes treated as a dummy variable. You are a man or a woman. I think increasingly, social scientists are moving away from trying to treat that as a dichotomous variable because it tends to force folks into 1 or 2 boxes that may or may not make sense for them. One of the nice things about dichotomous variables is that they can be mathematically manipulated in a way that we can't with other kinds of categorical variables. And the reason for this is if you think about what would happen if you took the average. If I had a data set in which I had people who voted coded as 1 and people who didn't vote coded as 2, and there were 1,000 people in that data set, and I found that 550 voted. So I have 550 ones. I tally that up, divide by 1,000. I'm going to have 0.55 or 55%, or an average of 0.55. that mathematical process of adding and dividing the way that we would do for an average has like an intuitive meaning with a dummy variable that it doesn't have with a Likert scale, because with the Likert scale, the numbers that we're choosing are kind of arbitrary, whereas there's an entire class of mathematics that focuses on thinking about 0, 1 kind of variables and what we can do with them mathematically. And so there's actually some pretty robust things that we can do with dichotomous variables, not just in terms of mean, median, or mode, or charts and graphs, but we can use that idea of a dummy variable as a member of a category, not a member of a category, to take other categorical variables, whether they're nominal or ordinal, and rewrite them as a series of dichotomous variables. And so if you have 3 categories in your ordinal variable, you can have 2 dichotomous variables. Are you a member of category A? Yes or no. Are you a member of category B? Yes or no. If you answer no to both of those and the categories are exhaustive, you must be in category C. So you can use dichotomous variables to rework other ordinal variables, and that allows for us to sort of throw them into more advanced statistical analyses and get more leverage out of our categorical variables. Okay, a third, fourth, fifth, I forget where we're at, type of measure is interval ratio. I tend to use interval ratio and continuous sort of interchangeably. Technically, there's an important distinction between interval measures versus ratio measures. I'll try to highlight that, but I think a lot of folks in practice don't pay as much attention to this as they should. They just sort of treat these as variables you can do math on in most situations. So an interval measure is one that can take on a wide number of values. So you can sort of count with it, but it's on a subjective scale. And the example I think is most intuitive is temperature. And so Fahrenheit can be counted, right? We can measure the degrees, and we can say that 10 degrees, today is cold. And if it goes up to 20 degrees, we've increased by 10. And if it's 80 degrees and we increase by 10, that's the same like distance, that's the same kind of measurement. But the scale, the 0 point on that is really arbitrary. In Fahrenheit, the 0 point is based on the freezing point of ocean water, salt water. Whereas with Celsius, it's based on the 0 point of just freezing regular water. And its upper end is boiling. And so that's how it kind of maps itself out. Or I think the 100 point on Fahrenheit is like essentially the human body. So they're set up both to measure something, and we can sort of count and talk about, 10 degrees change, and that has mathematical meaning, but we're talking about scales that just don't really exist in any sort of objective sense. Whereas with ratio variables, there is a meaningful 0 point, that something important happens at 0, and we move into a different kind of way of thinking about things when we're going below 0 or above 0. So thinking about age as a ratio variable, age is something that we can count. We can do math on it. We can talk about somebody who's twice as old as somebody else. But 0 is like a meaningful value that you can't be younger than 0. And that's sort of like a fixed point. Similarly, if I was thinking about like savings, right? Positive values, I can count those up. Those are mathematical meaning. If I hit 0, that means something. It means I have no savings. And if I go negative, that means I'm in debt, I guess. And so that's sort of a state change that happens with that 0 point. And so ratio variables have that sort of meaningful 0 point in a way that interval variables don't. Is this an important thing to pay attention to? Maybe, maybe not. But it is, I think, worth throwing out to kind of have in the back of your head that there may be situations where that matters. Okay, I also want to talk about, I guess, complex measures that we are creating by smashing other things together. And so indexes and scales oftentimes work this way, where we have multiple indicators. They might be conceptually related to each other. They might be different ways of measuring the same thing. And we're just going to kind of smash them together to create a more general concept. So I'll give you two brief examples. So there's the misery index, which is something that I really despise, which is a measure of how bad the economy is. And so the idea is that you take the unemployment rate, which high unemployment is bad, and you take inflation, and high inflation is bad, and you add those two things together. And if you end up in a situation where you have high unemployment and high inflation, well, that's really bad. And so the idea is that we're measuring a bad economy in two different ways, and we're putting them together to get maybe a more robust measure. Maybe. I'm skeptical. Another example would be the polity scale. And so I'll talk about this because I'm going to talk about it later, where researchers identified something like 20 different attributes of authoritarian regimes and 20 different attributes of democratic regimes, and scored them in terms of are these things present or not present, and then just added up those scores to get sort of a measure of how democratic or authoritarian a country is. Right? And so they're building it from a variety of different pieces. And as we talked about sort of deductive conceptualization, where you sort of say these things are necessary or important part of my definition, essentially that's kind of what we're doing with building a scale like that. Is we're saying these are various different components that have to go in. We're going to measure them maybe with dichotomous variables, yes or no. And then we're going to tally that up to kind of get a sense of how democratic or authoritarian a regime is. So we can do a lot with index variables and scale variables, and particularly in the social sciences with concepts we're interested in, oftentimes don't have easy ways to measure sort of complex concepts. We tend to rely on these kind of measures a lot. We can also think about typologies, and typologies are a way of sort of working with a couple different categorical variables to kind of put them together to create distinct subcategories. And so I oftentimes talk about regime type as the two attributes of a democratic system, right? Elections versus no elections, and then civil liberties and civil rights versus no civil liberties and civil rights. And so we could talk about a democracy as one where both of those categories, you have elections and there's civil rights and civil liberties, that's met. Typically, when we think about authoritarian regimes, we think about regimes where there's no elections and there's no civil rights and civil liberties. But that's not a guarantee. We could also have a category of no elections, but there are civil rights and civil liberties, sort of a liberal authoritarian regime, liberal in the classic sense, not the left-right sense. We could also have an illiberal democracy. We could have a regime in which there are elections, but the elected leadership doesn't respect the civil rights and civil liberties of the population. We could have an illiberal democracy. So there's ways to use these categorical variables to maybe create additional refinements to our concepts. And I think that's kind of worth having in the back of your mind as part of the social scientist toolkit. But I do want to flag some pretty big concerning things that can happen with indexes. And I think just recognizing how subjective these things can be is important. So the first thing I'll say is that oftentimes when we are smashing lots of things together into a complex measure, we sometimes don't always think about, is this appropriate for the research question I'm asking? And I'll be very specific here because I think it's a little abstract to what I just said. Political scientists for decades have used the polity score, that measure of authoritarian versus democratic regimes, to analyze all sorts of political questions because it's really handy and the data goes back like 220 years or something. But one of the measures that got smashed together is there a peaceful transition of power, or is violence surrounding elections? And that's really relevant for thinking about measuring democracy versus authoritarianism. But we're also using that variable of the polity score to look at things like how likely are civil wars to break out. And it turns out that if you observe a civil war breaking out, you're going to have a lower polity score because that's going to also correspond to violence around elections, most likely, or non-peaceful transfer of power, and that's going to drive your polity score down. So we've essentially created, as a definitional issue, a link between those variables because we didn't anticipate using that variable to study that particular question. And so we try to avoid measuring the thing we're trying to explain as part of our sort of explanatory variable. I hope that makes sense. Another problem that comes up with building indexes and scales, and I think this is much more universal and everybody has to wrestle with this, is how do we determine the appropriate weight for each item? If we have scales, like Likert scales, and it's everything's from -2 to +2, and we're adding 5 Likert scales together, maybe that's appropriate. But maybe it's not. Maybe one of those scales is really central to what we're talking about, and a couple of the scales are more tangential. Like, should they all really be weighted equally? And we kind of need to figure out how to deal with that, because it's not enough to simply say, I will just throw all these things in and have them be equal. Is that justified? We should at least have a mental conversation with ourselves about that. So that's sort of the philosophical piece about it. And there's just the mechanical piece. If you have one variable that's measured on a 1 to 5 scale and another variable that's measured on a 1 to 100 scale, and you add them together, the 1 to 100 scale is just going to completely obliterate and roll over the top of that 1 to 5 scale. So you're going to want to make sure that if you're adding them together, that they're appropriately adjusted so that that adding process actually makes sense. This might seem silly. It happens. It's flagging. Pay attention to what's happening mathematically when you start smashing things together. And then lastly, we should really wrestle with what do we do about missing values? Because when you start smashing multiple variables together, there's a good chance that some of those variables are going to have missing values. And do we treat those missing values as zeros? In which case we have cases that have artificially low index values, not because they're low, but because we didn't have a value to add together in this one measure. Do we simply say that that entire index value is invalid because we don't have all of the various different pieces that go into it? There's a variety of ways to handle it, but I think, again, before you start just adding things together in Excel or whatever statistical package you have, you want to have that conversation with yourself about what do we do when we have missing values and how are we going to treat that and what does that mean mathematically?